All right, welcome. So I had some questions about the Postlab for the mass percent composition and chemical formulas lab. So there's 4 questions on this Postlab at the time of this filming, and we'll just go through them one by one. All right, so the first question it asks you to calculate the percent anhydrous in your compound. Okay, so that's going to be equal to the anhydrous part over the original mass. And then we'll need to multiply that by 100%. Okay, generally speaking, for any mass percent, you want part over whole. Okay, and said another way, that whole will include the mass of the part. In lab, we calculated water percents. This is going to be the exact opposite. Like in lab, we had water percents. It could have been like, 20% or something like that. So if you had a 20% water mass, that means your anhydrous would be 80%. It's going to add up to 100. So in this example, to calculate the anhydrous percentage, we're going to need to get the anhydrous mass first. So going by my pictures, I need the red stuff. So here I have the beaker and the red stuff. So that's going to be C. And I want to get the beaker mass out. That's going to be an A, C minus A. And that will get you that answer. All right. And then for the mass of the original compound, the hydrate, and the original mass, the hydrate, we want all of it. So that's going to be B minus A. Right? So we'll call this, I don't know, E. We'll call this F, something like that. So to get your percentage, you're going to do E divided by F here. And make sure you multiply your answer by 100% so that you get a percentage. Okay, and then just a usual reminder about sig figs. Everyone gets different problems, but the way it's written into the Canvas quiz, it looks like everything goes to the 100th place, the second decimal place. But once you do your subtractions, you'll stay in the 100th place, but how should I say this? Everything that's written on the website appears to be 5 sig figs, but I'm sure once you do some of these subtractions, it's not going to be 5 sig figs anymore. So just keep that in mind. All right, next question. All right, the next question asks us to determine the amount of waters in this chemical formula. I don't want to do the exact problem for you. I mean, part of me just says, oh, that'd be easier. But no, I want you the challenge of figuring out some of that process. And, that being said, I think the best way to do that without actually doing the problem is to show you how to do the exact same process, just in a different example. So we have a magnesium sulfate with some amount of water. That water is 51.1% by mass. The molar mass of the entire hydrate is 246.47, and water's molar mass is always 18.02 grams per mole. All right, so the way we want to set this up is, I think we'll do this in 2 parts. So part 1 will be to find the molar mass of H2O only in the chemical formula. All right, let's just do it before I tell you part 2. So we have 51.1%. That's the water percent. So if we turn this into a standard number, and then multiply it by the molar mass. That'll give us the molar mass of all of the waters in this chemical formula. So I'm going to just divide this by 100 immediately, just so I get it as a standard number, 0.511. All right, so to get the molar mass of just waters, I'm going to do 0.511 times 246.47 grams per mole. All right, and that'll get us something. All right, 126 grams per mole. I don't think we need to carry extra digits here. We can just follow sig figs on the fly. All right, they have you round to a whole number anyways in this problem. All right, so the second part of the problem, I need another paper. All right, well, let's write it. Part 2 is to find the number of H2O molecules. Okay, so 126 grams per mole. This represents the total molar mass of all H2O. And we're going to divide it by 18.02 grams per mole. And that tells us the molar mass of just one H2O. Okay, so all the waters divided by how much molar mass just one water has, that will tell us how many waters we have. And we're just going to round this to the nearest whole number. Okay, well, I'll just use the existing calculation on my calculator divided by 18.02. And we get 6.989, 6.99. That will just round to 7. Okay, so that's magnesium sulfate heptahydrate, 7-hydrate. I think Canvas just wants you to write down that sort of number. A way you can guess and check your work is 126 plus 7 times 18.02. That's 1 water, and that's the not water part. Not 126. Hang on, I lost my train of thought. Pause. Okay, no, that was wrong. The way you could check your work, not that, would be to calculate the molar mass manually and see if we get the original number they gave us. For magnesium sulfate, that'd be 246. You'll be doing this for 293.15 or whatever problem you end up having. But yeah, let me see if this works for magnesium sulfate. So let's see, 1 magnesium is 24.3031. All right, and then I have a sulfur at 3206. Okay, that's sulfur. Oxygen 16.00. I need 4 of them. So I have a 4 there, and then I am going to have 7 waters. So I'm going to use 7 times water's molar mass is 18.02. That 18.02 just comes from a hydrogen, another hydrogen, and then an oxygen. 18.02 depending on how many sig figs your periodic table has. So basically what I'm saying is if I have 7 waters, I should be able to test that out by calculating the molar mass manually. All right, so let's see if this holds water, pun intended. Oops, plus 7 times 18.02. Moment of truth, do we get something pretty close? 246.47. We got 246.51. So within rounding error of the data provided and whatever periodic table you may have. So I'd be happy with that. That checks out. All right. So yeah, and I mean, if you really want to play the game, you could calculate this part for here, and then you can just cycle through numbers 1, 2, 3, 4, 5, 6, 7, etc. until you get that. Clever, but I'd rather you do it this way just to fully learn the process, but I can't control you. All right, next problem. Okay, so number 3, it reads, the student found 2 unlabeled containers in the lab. Both of them have a similar crystalline white appearance. La, 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 la. So the labels were dropped, and you don't know which label belongs to which of the 2 bottles. So it says one label says ammonium nitrite, and the other says ammonium carbonate. And then the student analyzed the compounds and found that the 2 compounds, interestingly, had the same percent of oxygen. Okay, within rounding error, I'm sure. I mean, it's not going to be exactly the same, but it's going to be almost exactly the same. So, and then they ask you to round all atomic weights in your problem to the 100th place. And that might dictate the sig figs as well. Okay. So yeah, if we're going to the 100th place, then that's probably going to end up being 3 or 4 sig figs on that percentage. Yeah, probably. Okay, anyways, let's just do the problem. So let's see, number 3. What did they say? Ammonium nitrite. Okay, and I know not all of us have gone to naming yet in lecture, so I'm happy to help here. Ammonium nitrate, and the other was ammonium carbonate. All right, so ammonium is NH4+. All right, it's one of the few polyatomic cations you'll learn this semester. All right, and nitrite, not to be confused with nitrate. Nitrate is NO3-. Nitrite, it just means you have 1 less oxygen. Everything else is the same. Ammonium nitrite is NO2-. All right, and then we have ammonium carbonate. NH4, and then CO3, 2- carbonate, CO3, 2-. Okay. Yeah, so if you're just wondering, what's the relevance of these random compounds? Ammonium is what you make when ammonia, precursor to fertilizer, is in acidic environments. You make ammonium cation. And carbonates, common in many soils, minerals. When you drink a soft drink, you're drinking carbonic acid. Okay, carbon dioxide reacting with water, you make some carbonate anions. All right, so the question becomes, what the heck are the chemical formulas going to be? Well, hopefully you see here, we just need 1 of each to charge balance. So this will be your chemical formula for ammonium nitrite. To take inventory of what elements we have here, we hopefully see you have 2 nitrogens, 4 hydrogens, and 2 oxygens. All right, let's go to the ammonium carbonate side. Since carbonate has a 2- charge, we will need 2 ammoniums to charge balance the carbonate. If you like doing something like crossover method, we can do that. Just make sure if there's a common multiple in the final answer, you remove all those common multiples. We're not going to have something like that here. So the 2 will go there, and then the 1 will go there. And then you just drop the ion, so NH4. For a polyatomic ion, if you have more than 1 of it, you need parentheses. And then the carbonate, since there's only 1 of it, we actually will not need the parentheses. So the final formula, the correct way to write it, will be that way. right, hopefully that made somewhat sense. We can touch on that more in lecture if need be. All right, so to keep tabs on how many we have of each element, when you have a subscript for a polyatomic ion, it multiplies to everything in there. This to me is saying that we have 2 of these ammonium. So we have 2 times 1, we're going to have 2 nitrogens. 2 times 4, we're going to have, not 4, we're going to have, here, let me just rewrite this. 2 nitrogens, 8 hydrogens, 1 carbon, and then 3 oxygens. Okay. And then they're asking you to get the percent of oxygen in each of the compounds. So that means you'll have to use the periodic table for these elements. Okay. Nitrogen's a 14.01. You go 2 times 4 times 1.01 for the hydrogen, and then you'll go 2 times 16.00 for the oxygen, and then add them up. And so basically, here, I'll use red for oxygen. Okay, red box. And then I'll use blue for like everything. So using the periodic table to get the percent oxygen by mass, then you would do the oxygen mass, which I have boxed for those 2 oxygens. And then you're going to divide that by the total, which includes the oxygens in the blue box. So that'd be the total mass. And of course, if it's a percent, take your final answer and multiply it by 100 in your calculator. So if you do everything right, you're going to do it for this compound and for that compound, and you should get the same oxygen mass for both of the compounds. Okay. You want an example of me doing for a compound? I could do like we talked about. Actually, let's just do this. Let's say I wanted to percent calcium in calcium chloride, CaCl2. So I would calcium's a 40.08. Chlorine, that's going to be 2 times 35.45. And that's going to be 70.90. Okay, so to get the total, I would go 40.08 plus 70.90, and I would get that much grams per mole, 110.98. So to get the percent calcium, I would just go, let's see, there's my calcium. I only have 1 of it, so 40.08 divided by the 110.98 grams per mole, they cancel anyways, times 100%. (36.11%). If I wanted the percent chlorine, I would take the 70.90 and divide it by the 110.98. Or if I only have 2 elements, I could do 100% minus the 36.11, and it should be the same answer. Okay. With your problem with ammonium carbonate, you have multiple elements going on, so you don't have that luxury. Anyways, okay, and then let's go to number 4. All right, number 4, actually, we kind of explained a lot of how to do that. So number 3, how do you calculate oxygen percentages? For number 4, they want you to calculate the nitrogen percent of each of these compounds, but only one of them will have a mass percent of about 29%. So whichever one is 29%, again, it's only going to be one of these, you'll calculate you'll type in the chemical formula for that compound. So if ammonium nitrite was the one with 29%. And I don't have to have any poker face here because I honestly, I don't remember which one has the 29%. But if this one did, you would type the chemical formula like that. If it was the ammonium carbonate, you would type it in like that. Of course, in Canvas, we don't always have the ability to type subscripts. So you would just go like NH4NO2. And then for this one, if you were to type that one in, you'd be parentheses NH4 close parentheses 2 CO3 like that. All right. Yeah. Thanks for the question suggestions. I hope this helps, and let me know if you have any questions. Have a good night. Take care.